Hello students, today you got be checking your practice problems for section 5.3. And number 10, when writing electron configurations, what general order are the sublevels? And they are in order. Increasing energy. Number 11 has number of electrons in energy sublevel illustrated. As a superscript. On the sublevel. And we want some electron configurations. Anytime it says write electron configurations, you can use the noble gas configuration, or you can use a conventional straightforward. But we got sulfur. And here I'm going to write the complete one. Start with sulfur. We move through element number 16. So we go through 1s2. Take care of first period, second period. We got 2s2. That takes us up through beryllium on our periodic table. And third, then we got 2p6. And we get to energy level 3, or period 3, which refines sulfur. And we use a 3s2. And then sulfur is the fourth one over in that p box, so 3p4. Quick check, all your exponents should add up to the atomic number, and I got 2 plus 2 plus 6 plus 2 plus 4. Okay, 6 and 4 is 10, and 6 more, 16. Checks. And we got calcium. Ca, element number 20. Here we use the short notation. Either one works. And calcium, we look at its preceding noble gas, which is been over argon. And calcium's in our S block. And we're in period 4. That's 4s, and it's the second one, 4s2. Bromine, Br, element number 35. We find it in period 4. The key information we need. So, noble gas configuration, what we use most of the time, unless it tells you to write it complete, then don't use it. So I got argon up and over from bromine, and we go down to the bromine's row, which is the fourth, and we see 4s2, and we move over to D's. D's off by 1, so 3d10. And we have 4p, and we 1, 2, 3, 4, fifth element over, 4p5. Magnesium, Mg, element number 32. not element number 32. Element number 12, where I got 32 at. Element number 12, and is in the third period. So our noble gas preceding magnesium is neon. Then we got 3s2, as magnesium's in the S block. Head the second one over. Now this one says use noble gas configuration, so all these will. Fluorine, and when they're in the second period, as fluorine is, fluorine element number 9, second period. Really doesn't make any difference if you noble gas or standard notation. But we start with helium, the noble gas preceding it. We move down to our second row, and 2s2, and we slide over and we find fluorine in the P group, so 2p, and it's the fifth element in that P group, or P block. So helium 2s2, 2p5. Phosphorus, so P, element number 15, and here we're in the third energy level. So we go to neon, the noble gas preceding, and then we go to phosphorus's row, the third row on the periodic table. We got 3s2. And through the S block, and we go over into the P block, so we're at 3p, and phosphorus is the third element in there. Lots of electron configurations here, very key idea. We have already went and looked at little what the textbook is going to have in chapter 6 with the box and the way I have you figure out the electron configurations. Calcium, element number 20. We're in the fourth energy level. So we look at the preceding noble gas, argon, and then 4s, and calcium is the second one in there, so that's it. Argon 4s2. Cobalt, CO, element number 27, and here we're in a D block, and we're in the fourth energy level still. So cobalt, start with an argon, and then we got a 4s2, and then we move into the D block where we find cobalt. And it's off by 1, so it's going to be 3D, and it's 1, 2, 3, 4, 5, 6, 7th one over. So 3D, 7. Selenium, element number 34, symbol Se. In selenium, we also find in the fourth energy level. So that means you still start with argon, up and over to the third row, and then we go to the row that our selenium is in, and we find a 4s2, And we go all the way across the D block, 3D10. And we move into the P block where we find selenium and find it as the fourth element in there. So 4P4. Technetium. Technetium is number 43. Our symbol TC. We're still in the fourth energy level. Oh, we're in the fifth energy level now. Looked at that periodic table incorrectly. Fifth energy level. So we go up and over, and we find krypton. And we got 5. And we got a 5s2. And then technetium's in the D block. D's are off by 1, so that'll be a 4D. And it's 1, 2, 3, 4, fifth element in there. 4D5. And iodine. Iodine is element number 53. Symbol iodine. Iodine's in the fifth energy level. So we go up and over. We got krypton. And then we got 5s2. And then 4D10, taking us all the way across the D block, and we get to the P block, and we're the fifth one into it. So it is 5P5. Holmium. We find down in the bottom in the lanthanide series. So that is actually part of period 6. So holmium HO, element number 67 in period 6. So we find our preceding noble gas, which would be xenon. And we do a 6s, and we move all the way across the S, 6s2. Then we drop down to the F block. F's are off by 2. So not 6F, but 4F. And 4F, and we count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11th one in that F block. Iridium. Iridium, IR, element number 77, also in the 6th energy level. So we start with preceding noble gas, xenon. And then we're going to go through all the way through the S block, so 6s2. We go all the way through the F block, off by 2 for F14. And we come back up to our D block, and we got 1, 2, 3, 4, 5, 6, 7th one over 5, D, 7, as the D's are off by 1 in their energy level. Radium is our A element number 88. And now we're down to the 7th energy level. So we take our preceding noble gas, radon, and then we go to 7, and we're second element in the S block, 7s2. And right electron dot structures for following elements. So nitrogen, we got an N. N is in period 15 or 5A, meaning it has 5 valence electrons. So we put 5 dots around it. I always put the first 2 together and then single, single, single. Aluminum, Al, group number 13 or 3A is telling us we have 3 valence electrons, and we'll go 2 together, 1 separate. Our textbook, if you see it in there, they'll probably have 3 separate dots. Not the best way to write it. Because first 2 dots together correspond to that S sublevel. Neon, one of our noble gases. Group number 18 or 8A, 8 valence electrons, and we get 4 pairs. Strontium. Strontium, we got Sr. Strontium is in group number 2 or 2A, and it only has 2 dots, 2 valence electrons, and we'll put those together as a pair. That doesn't matter which side you put it on. You could put them on the top, bottom, or on the right also. Antimony, symbol SB. Antimony, group number 15 or 5A, same as nitrogen was a while ago, so we're going to get the first 2 together, need 5, then single, single, single. Iodine, I, one of our halogens in group number 7A or 17, having 7 valence electrons, 2, 3, 4, 5, 6, 7. So you end up with 3 pairs and a single. Lead, Pb. Lead is in group number 14 or 4A. Textbook, again, would put 4 single dots. I like a pair and 2 singles. It shows a better illustration of the electron dot structure. Cesium, Cs, is in group number 1, or 1A. It's 1 valence electron, so only get 1 dot. And what electron dot structure is shared by all noble gases except helium, and it is 8 dots. And list 3 elements that have the electron dot structure given here. And we see we have 5 dots. meaning we have 5 valence electrons, which means it's in group 15 or 5A. So anything out of group 15 or 5A. So you could have picked nitrogen, phosphorus, arsenic, antimony, and bismuth. So any 3 of those. That takes care of this little group of practice problems. That's all for now.